Welcome to example 3.1. Example 3.1. It says a set of three unbalanced voltage pairs of VA, VB, and VC are given. Calculate the positive, negative, and zero sequence components of these phasor voltage phasors and indicate on approximate diagrams how the different sequence components are located. Take VA as a reference. VA is our reference. So if VA is our reference, it means our VA1, which is, of course, if you want to find that positive sequence of that component, positive sequence of that component, VA1, from our formula last time, we said is 1/3 VA plus alpha VB plus alpha squared VC. If you remember that formula. So to find the positive component, it has to be 1/3 into what is our VA. Our VA is given as a 225 at angle minus 38 degrees, then plus our VB, which is 175.69, 175 at angle 69 degrees, plus the alpha. Alpha represents 120 degrees, right? Then plus alpha squared VC. What's our VC? Our VC is given as what? 140 at angle 115, 140 at angle 115 degrees, plus alpha squared, which is 240 degrees. So when you find that one, it gives you 76.329, 76.329 at angle minus 51.06 degree voltage. That's the positive components, because we are asked to calculate to calculate the positive, negative, and zero. So what is the negative one? The negative one will be VA2. VA1 is the positive one. VA2 is the negative one, which is 1/3 into what? Into, remember we calculated, we worked it out last time. It will be VA plus alpha squared VB plus alpha VC. That is the negative component. So it will also be 1/3 into VA. Our VA is 225 at angle minus 38 degrees, plus our VB. Our VB is given as 175 at angle 69 degrees, plus the alpha square, which is 240 degrees, then plus alpha VC. What is our VC? Our VC is represented by 140 at angle 115 degrees, plus alpha 120 degrees. So our component, negative component, phase component, will give us what? 146.964 at angle what? At angle minus 61.98 degrees volt. That is our negative sequence component. Then we have found VA1, we have found VA2. Now we need a VA0. And our formula for VA0 is 1/3. If you remember, our formula for VA0 is what? 1/3 into VA plus VB plus VC. 1/3 into VA plus VB plus VC. That's our VA0. So when you substitute this, what are you going to get for VA0? You get 78.691 at angle 40 degrees volt. So that is our VA0. So that is to find all the components for all the components, the positive, is negative, and the 0 component for A. Now we need to find the components for, you already found VA naught, VA1, and VA2. Now you want to find, and our VA naught, let's not forget I told you VA naught is also the same as VB naught. It's got to put also VC naught. So that's one. Whatever you get as this is also equal to VB naught, and it's equal to VC naught. So that's that one. But now to find VA1, to find VA1, to find the VB1, you have found VA naught, VB naught, VC naught. You have to find VB1 and VC1. You want to find VB1 and VC1. To find this one, this is the positive component. So you draw the phasor for the positive. That's VA1 is the reference, positive, VB1, and VC1. So your VB1 is here, which is alpha is advanced at anticlockwise. That is alpha squared VA1. So VB1 is alpha squared VA1. VC1 is alpha squared VA1. It's alpha VA1, alpha VA1. So whatever you find as your VA1, let us assume that we find our, when we found our VA1, we found it to be what? Our VA1, we found it to be 76.329. 76.329, 329, sorry, 0.329, 76.329 at angle minus 51.6, minus 51.06 degrees. Then, because it is alpha squared, you have to plus 240 degrees to it, and that will give you your VB1. The same thing for VC1. For VC1 also, whatever your V1 is, which is 76.329 at angle minus 51.06 degree, because it is alpha, which is 120, you add 120 degrees to it. That will give you your VC1. And when you want to do VB2 also, well, VA2 is this, then you will find your VB2 also, and VC2. So to get that one, you use the negative sequence phasor. So while your VA2 is the reference, VA2, because they said taking A as our reference, so it is A that will be referenced also. So VA2, VB2, and VC2. So our VB2 is alpha squared VA2, alpha squared VA2, and our VC2 is alpha, our VB2 is alpha VA2, and our VC2 is alpha squared VA2. So whatever you have as your VA2 that you calculated before, you advance it by 120 to give VB2, and you advance also VA2 by alpha squared, which is plus 240, the angle, phase angle, to get VC2. And that one you can just plot it on the same, just plot it on the phasor that you draw out. That is all they are asking for there. Thank you.